Hello everyone. Today we are going to do this project taking input from an ultrasonic distance sensor, and we are going to give the output of this sensor to the serial monitor. At the moment we'll work with the serial monitor and then we'll decide on some other kind of an output device. Okay, for this we are going to use one Arduino. Yes. Second is we are going to use an ultrasonic distance sensor. Now, the one that we are going to use is a 4-pin one. Okay, so we have actually two ultrasonic distance sensors. One is having 3 pins, one is having 4 pins. So we are going to use, at the moment, we are going to use the 4 pins one. You can find it in all components and you can search for Ultra and you will actually look at it. All right, so let's start working on this. SR04 is the number. This is actually the physical component also with the same number. All right, let us understand the pins. The pins are going to be VCC, which we know is positive power, and we have we have ground, which is the negative power, and we have two pins. One is called as a trigger pin, and one is called as an echo pin. Now let us understand how this thing actually works. You will find that there are two sensors on both the sides. One is actually called as a transmitter. This is basically a speaker which actually transmits, and you will find a T written on that side. We'll call this as a transmitter. T is for transmitter. On the other side is a microphone, which is basically a receiver. On that side, it is written as R. So what basically it does, this particular sensor does is it gives out ultrasonic sound from this particular sensor, from the transmitter. This sound travels exactly in front, right in front, and the sound may find an obstruction or may just go on and on and on and never be reflected. But if it finds an object in between, so there is an object, maybe say 10 centimeters or 20 centimeters or 30 centimeters from this particular transmitter, the sound wave is going to be reflected by the object, by the obstacle. And when it is reflected, that reflected sound is received by the receiver. All right. We are going to connect both the trigger and the echo using digital pins. We do not require PWM for it. Okay. So let us do this. I'm going to put this here. Let us now, okay, I would need power, so I will need that to be visible. All right. So VCC is positive power. Let's give it positive power. So we are going to give it positive power. This is red in color. And this is ground. And here comes ground. And let's color this as black. Now we have two pins. One is called as a trigger pin. Let's connect it to any digital pin. It doesn't matter whether it is a PWM or otherwise. So let's connect them to pin number 9 and pin number 8. And we can see that we have connected the echo to pin number 8 and the trigger to pin number 9. Let's color them. Okay. This is all the connection that we will require, and basically we are going to give output onto the serial monitor, so we don't need any physical connections for it. Okay, now uh, uh, let's start programming for it. Okay, so what is the code going to look like? All right, let's remove the extra code from here and let's leave only the code that we require. We require the setup and loop. How many pins are we using? We are using a trigger pin and echo pin. So we are going to have both as trigger trig pin is equal to trigger pin is connected to pin number 9, and int echo pin is connected to pin number 8. So that is what we require. Now, trigPin is basically giving output to the sensor. So it's basically an output device now. So we will take pin mode. Let's make this bigger. All right. So pin mode in brackets, trigPin, comma, trigPin is an output device. Output. The second one, which is the echoPin, we'll say pin mode. I should write that as capital M. Okay. This is echoPin, and echoPin is an input pin. Okay, that part done. Let's start off with the loop. And in the loop, we are going to, first of all, work on sending some information to the sensor. Okay. So that means we are going to, first of all, as I told you, that the sensor basically works with sound, and ultrasonic sound is basically sent from the transmitter and received from the on the receiver. So let us send some sound. Okay, how do we send the sound? Is by a digital write. So I'll say digital write, and which is my pin, that is a trig pin. So I'll say trig pin comma low. So what am I going to start off with is that I'm going to ensure that in the beginning the trigger pin is not sending anything. So that means it is off at the moment. After a delay, and I'm going to give a delay in microseconds. Microseconds. And how many? For 2 microseconds. So for 2 microseconds, we are going to give an output of, we are going to delay. Next, I am going to send a high to through the trigger pin. So that means it is now giving out sound. For how long is it giving out sound is for around 10 seconds. And then I will switch off the trigger pin again, and make it as low. So see what is happening. First of all, we ensure that nothing is being sent from the trigger pin. That means no sound is going. We wait for some time. That is 2 microseconds now. Please remember, it is not milliseconds. It is 1 millionth of a second. And for around 10 microseconds, we give a high to the trigger pin. So that means the trigger is giving out sound now for around 10 seconds. And after that, immediately after that, we set the trigger pin as low. That means there is no sound. So that means it basically sends out a burst of sound from the transmitter and then stops. What else? Now, if the sound has been sent, I need to receive. I need to figure out how long it took for the sound to go from the transmitter to the receiver. So that means from the transmitter to the obstacle and back to the receiver. For that, we have a new function that we are going to use. We call it as pulseIn function. So Pulse in function. To the pulseIn function, we send two uh, two arguments. One is called the pin, that is echoPin, and then we write high. I'll explain to you what this means. And the input of the return value of pulseIn function is going to be stored in a variable called distance. Now let me explain what this function actually does. pulseIn function is given echoPin and high as the arguments. So see what happens. Now what happens is when the sound waves hit the receiver, it turns the echo pin high for however long the waves were traveling for. So this means when, I'll repeat again, when the sound waves hit the receiver, it turns the echo pin high for however long the waves were traveling for. So if the waves were traveling for 2 seconds, echo pin becomes high for 2 seconds. That should be very clear to you. So if the wave took 2 seconds to return to the receiver, the echo pin is going to be high for 2 seconds. And that is what we are going to record. So the longer the wave takes to reach the receiver, the longer the echo pin is going to be high. Now what we have written is high over here. If I had written a low over here, the duration basically will tell how long was the echo pin taken as high. So that will be in seconds. So if I know the time taken for the wave to return to the receiver, what is the distance that it covered? We can use a formula, speed into time. So I can say distance into distance is equal to, it is basically time into speed, time multiplied by speed. So what is the time actually time taken? And the time taken is duration, and multiplied by speed of sound, which is 0.0343 or something. So now we need this distance that is there. This distance would be actually for the wave to go to the obstacle and return from the obstacle. So that means the distance covered by the wave is double, actually going to the obstacle and returning from there. What is going to be the actual distance now is going to be divided by 2. So that is the distance of the object, that is the obstacle, from the transmitter. We can now display the uh, information using print. So I can say distance, and I can say serial dot println distance. Now you know what is the difference between that distance and this distance. The distance in double quotes is actually just a message, so it will be displayed as a message. Whereas this distance in not in double quotes, which is actually a variable which has been created by us, will actually show the actual value. Let the program is complete now. We have actually we have given out sound, the burst of sound. Actually, the burst of sound was only from this one. The before and after thing was actually giving out a low. That means it is switching off the speaker, the transmitter. Here it transmits, here it stops again. And that you can see what is the delay over here. Let me give a delay here, delay of 100 milliseconds in between these bursts. Okay, so let's run the program and see how things go. Let's see the serial monitor is showing a distance of 91. Here also it is showing a distance of 91.9, so both are almost similar, so there is no problem. Let me change this distance. If I change this distance to, you can say 113, 115, 131, and if I bring it closer, it is 88, 81, 89, and so on and so forth. So we are measuring distance properly, so there is no problem. So let me stop here. It is showing me 77.7. Here it is showing 77 here, so we are still pretty close to the actual. Okay. Let us see the program again. The program was the trigger pin and echo pin were connected to pin 9 and 8 respectively. Both the pins have been shown as output and input pins. Serial monitors, serial communication has been started. Next is this is sending out a burst of sound from the transmitter. This is receiving sound back from the transmitter, from the obstacle. So whatever I have explained to you how this thing works. This is actually the duration of time it took. So maybe it is 2 seconds, maybe it is 5 seconds. So 5 multiplied by whatever this gives it gives me the entire distance covered, divided by 2 is actually the distance between the obstacle and the transmitter and receiver. This is actually displaying the values, and that's it. Okay, now this covers this part. We are going to do in the next program, in the next project. We are going to work with again the same ultrasonic distance sensor, but with the output not going to the serial printer, serial printer line, but to a device, maybe a motor, maybe a light, maybe sound. So we'll work on that. Anyway, thank you for watching. I'll see you in the next video now.